In high-energy physics, a vector meson is a meson with total spin 1 and odd parity, compared to a pseudovector meson, which has a total spin 1 and even parity. Vector mesons have been seen in experiments since the 1960s, and are well known for their spectroscopic pattern of masses. Since the development of the quark model by Murray-Gell-Mann, the vector mesons have demonstrated the spectroscopy of pure states. The fact that the I equals 1 rho meson and I equals 0 omega meson have nearly equal mass centered on 770-700-278-780-780 MeV, C2, while the phi meson has a higher mass around 700-310-200-1020 MeV, C2, indicates that the light quark vector mesons appear in nearly pure states, with the phi meson having a nearly 100% amplitude of hidden strangeness. This characteristic of the vector mesons is not at all evident in the pseudo-scalar meson or scalar meson multiplets, and may be only slightly realized among the tensor meson and pseudovector meson multiplets. This fact makes the vector mesons an excellent probe of the quark flavor content of other types of mesons, measured through the respective decay rates of non-vector mesons into the different types of vector mesons. Such experiments are very revealing for theorists who seek to determine the flavor content of mixed-state mesons. At higher masses, the vector mesons include charm and bottom quarks in their structure. In this realm, the radiative processes tend to stand out, with heavy tensor and scalar mesons decaying dominantly into vector mesons by photon emission. Pseudovector mesons transition by a similar process into pseudo-scalar mesons. Because much of the spectrum of heavy mesons is tied by radiative processes to the vector mesons, one may think of vector mesons as forming a sort of backbone to the spectroscopy of mesons in general. Some vector mesons can, compared to other mesons, be measured to a very high precision. This stems from the fact that they have the same quantum numbers as the photon, JPC equals 1-0. Therefore they appear in electron-positron collisions in the process, which provides experimentally a clear signal compared to other measurement, which have to use hadronic processes. Examples: rho meson, omega meson, phi meson, K** meson, D** meson, J psi meson, meson,